In this video, I will show you how to use the quotient rule to find the derivatives of rational functions. Let's say you have been told to find the derivative of u divided by v. This will be equal to v times u prime and then minus u times v prime divided by v to the power of 2, where u prime is the derivative of u and v prime is the derivative of v. Let's look at some examples. Let's say we are to find the derivative of the function 3x minus 2 divided by x to the power of 2 plus 9. How would you find the derivative using the quotient rule? Now in this case, u will be equal to 3x minus 2. And then what will be u prime? U prime will be equal to the derivative of 3x minus 2. If you differentiate 3x, you get 3, and if you differentiate negative 2, you get 0. And then v will be equal to x to the power of 2 plus 9. Then v prime will be equal to the derivative of x to the power of 2 is 2x, and then the derivative of 9 is 0. So this will be equal to v, which is x to the power of 2 plus 9 times u prime, which is 3, minus u, which is 3x minus 2, times v prime, which is 2x. And this will be divided by v, which is x to the power of 2 plus 9, and then to the power of 2. Now if we distribute the 3, we shall have 3x to the power of 2, and then plus 9 times 3, which is 27. And then if we distribute the 2x, we shall have negative 3x times 2x, which is negative 6x to the power of 2. And then we shall have 2x times negative 2x and then times negative 1, which will give us positive 4x. And then this will be divided by x to the power of 2 plus 9 raised to the power of 2. And now if we combine this and this, our final answer will be equal to negative 3x to the power of 2 plus 4x and then plus 27, and this will be divided by x to the power of 2 plus 9 raised to the power of 2, and that's our answer. Out another one. Let's find the derivative of x to the power of 4 divided by 2x to the power of 2 plus 3 using the quotient rule. In this case, our u will be equal to x to the power of 4, and therefore u prime will be equal to the derivative of x to the power of 4, which is 4x to the power of 3. And then v will be equal to 2x to the power of 2 plus 3. If we differentiate this, v prime will be equal to the derivative of 2x to the power of 2 is 4x, and then the derivative of 3 is 0. So this will be equal to v, which is 2x to the power of 2 plus 3 times u prime, which is 4x to the power of 3, minus u, which is x to the power of 4, times v prime, which is 4x, and this will be divided by v, which is 2x to the power of 2 plus 3 raised to the power of 2. If we distribute 4x to the power of 3, we shall have 4x to the power of 3 times 2x to the power of 2, which is 8x to the power of 5, and then plus 3 times 4x to the power of 3, which is 12x to the power of 3, and then minus x to the power of 4 times 4x, which is 4x to the power of 5. And then this will be divided by 2x to the power of 2 plus 3 raised to the power of 2. Now 8 minus 4 will give us 4, so this will be equal to 4x to the power of 5, and then plus 12x to the power of 3, and this will be divided by 2x to the power of 2 plus 3 raised to the power of 2. And if you want, you can put out the greatest common factor, which is 4x to the power of 3, and we shall remain with x to the power of 2 plus 3, and this will be divided by 2x to the power of 2 plus 3 raised to the power of 2. And that's our answer. Now you try out this. Find the derivative of sine x divided by tangent x using the quotient rule. In this case, u is equal to sine x. The derivative of sine x, which is u prime, will be equal to cosine x. And then v will be equal to tangent x. V prime will be equal to the derivative of tangent x, which is secant squared x. So this will be equal to v, which is tan x, times u prime, which is cos x, minus u, which is sin x, times v prime, which is sec squared x. And this will be divided by v, which is tan x to the power of 2. So this will be equal to tangent x times cos x, and then minus sin x. Now secant squared x can also be written as 1 divided by cosine squared x, which is also equal to 1 divided by cosine x times cosine x. So what we shall do, we shall divide sine x by cosine x and then multiply it by 1 divided by cosine x. And this will be divided by tangent squared x. This will be equal to tangent x times cosine x and then minus, now sin x divided by cosine x is the same as tangent x. So this will be tangent x times 1 divided by cosine x, which is secant x, divided by tangent squared x. And now if we pull out tangent x, we shall remain with cosine x minus secant x, and this will be divided by tangent squared x. Now this will cancel with that and we shall remain with 1, and therefore our final answer will be equal to cosine x minus secant x divided by tangent x. Now let's look at another one. We know that the derivative of cotangent x, this is equal to negative cosecant squared x. Now go on and prove this using quotient rule. This can be written as the derivative. Now cot x is the same as cosine x divided by sin x. Therefore in this case u will be equal to cosine x, and therefore u prime will be equal to the derivative of cosine x, which is negative sin x. And then v will be equal to sin x, and if we differentiate this, v prime will be equal to cosine x. Therefore this will be equal to v, which is sin x, times u prime, which is negative sin x, and then minus u, which is cosine x, times v prime, which is cosine x. And then this will be divided by v to the power of 2, which is sin x to the power of 2. This will be equal to negative sin squared x, and then minus cos squared x divided by sin squared x. Now if we pull out a negative, we shall remain with sin squared x plus cosine squared x, and this will be divided by sin squared x. And we know that sin squared x plus cosine squared x equals to 1. So this will be equal to negative 1 divided by sin squared x. And now if 1 divided by sin x equals to cosecant x, therefore 1 divided by sin squared x will be equal to cosecant squared x. So this will be equal to negative cosecant squared x. And that's how we prove it. And lastly, we also know that the derivative of secant x, this is equal to secant x times tangent x. Now you go on and prove this using the quotient rule. This can also be written as, now secant x is the same as 1 divided by cosine x. Therefore u will be equal to 1, and if we differentiate this, u prime will be equal to what? The derivative of a constant is 0. And then v will be equal to cosine x. If we differentiate this, v prime will be equal to negative sine x. So this will be equal to v, which is cosine x, times u prime, which is 0, minus u, which is 1, times v prime, which is negative sine x, divided by v squared, which is cosine x squared. Now cosine x times 0 will give us 0, and then negative 1 times negative sine x will give us positive sine x. So we shall remain with sine x divided by cosine squared x. And this can also be written as sine x divided by cosine x times cosine x, which is the same as 1 divided by cosine x times sine x divided by cosine x. And we also know that 1 divided by cosine x is secant x. So this will be secant x. And then sine x divided by cosine x is tangent x. So this will be tangent x. So that's how we prove this. That's all for today. If you have found this video helpful, don't forget to like it and also subscribe to my channel. Thank you for watching and have a nice day.